All right, boys and girls, here we are starting a new chapter, chapter 3. And chapter 3 is all about graphing linear functions. So, quick rehash stuff you should remember here. Let's talk about graphing points, just so we don't have any confusion later on. Remember that this is called the x-axis. Write this down. This is called the y-axis. On the x-axis, positive numbers are here, negative numbers are here. On the y-axis, positive numbers are here, negative numbers are here. So when we go to plot a point, we're not going to plot all of these. So this right here is 4, 2. So the first number is always the x. So it's right 4 up 2. That would be point A. Let's go here. E, 7, negative 4. So that's right 7, down 4. All right. Let's look here. F, negative 6, negative 10. So I would go left 6, down 10. All right. So again, most of you probably remember that, or after I said it a couple of times, you probably had something jog in your memory, but I want to make sure we talk about that before we talk about the rest of this chapter. So, the essential question, this, like I said, we are going to be graphing linear functions, so the question is, what is a function? A function pairs inputs with outputs. Information in, information out. When a relation is given as ordered pairs, the x-coordinates are inputs, and the y-coordinates are outputs. Make sure you emphasize that in your notes. Write this down. A function is something that pairs each input with exactly one output. That makes it a function. All right? Each input with exactly one output. So, copy that down, pause it if you need to. I'm moving on. We can find what a function is by an equation, by an input-output table, by words, by a graph, or a set of ordered pairs. And you're going to be able to do all of that today. Explain why the graph shown represents a function. So we said a function is each input with one output. So the x's, it's said in here, these are the inputs. These are the outputs. So each input, if I put 4, I get 0. If I put 3, I get 2. If I put 2, I get 1. Each input has one output. So this would be a function. We'll get into it a little bit more. But I want to talk about the inputs and the outputs. So, looking at it as a table. This means if I plug in 0, I get 8. If I plug in 1, I get 8. If I plug in 2, I get 8. If I plug in 3, if I plug in 4, they all come out to be 8. Is that a function? Or, if I plug in 8, I get a whole bunch of different numbers. So, as long as each one goes to this, is each number give an answer? Yes, it does. This is considered a function. These are all different, is the big key here. It doesn't matter if your outputs are the same. They can have the same output, just can't have the same input. So this right here, yes, that is a function. Down here, 8 gives me a whole bunch of different answers. So each input has one output. No, 8 has a bunch of different outputs. So that is a no. And it'll make a little bit more sense if we look at it graphically here in a second. But if your x's do not repeat, yes. If your x's do repeat, no. So, looking at it in this mapping here, so this is called a mapping. So, 1 gives me 8, 2 gives me 9, 3 could be 10 or 11. So this one has 2 different outputs, so this is a no. This information here, if we would write this in the other format, it would be 1 gives me 8, 2 gives me 9, 3 gives me 10, and 3 gives me 11. Because 3 gives me both answers. Whenever the x's repeat, it is not a function. You're going to see that coming up over and over and over again. If I look at it graphically, so 1 only has 1 output. 2, 3, 4, but right here, 5 has 2 different outputs. I showed you earlier, the inputs are down here, output here. So 5 has 2 different outputs, not a function, excuse me. Not a function. 1 input, 2 different outputs, whether I look at it in the mapping, whether I look at it in a table, whether I look at it in a graph. If 1 input has 2 outputs, it's not a function. All right, so looking at it all these different ways. Do any of the x's repeat? No repetition. So the first one here is good. Yes, that is a function. You should be writing these examples in your notes. Number F, right here. I have x's repeating themselves. No, not a function. So something to think about. It said that you have to do this in words. A radio frequency is a listening area that has exactly 1 station. So let's think about this. If I tune into, you guys don't even listen to the radio probably hardly anymore, but if I tune into 107.7, can I hear 2 different stations? Can there be 2 different possible outputs? No, that doesn't work. There's only 1 output. So yes, this is a function, okay? That's kind of a key word. H, same television station can be found on more than 1 channel. If I want to find, if I have a charter cable and I want to watch Channel 5 News, are there more than 1 way I can watch the Channel 5 News? Yes, there is. If I go to Channel 5 or if I go to 705, there's 2 ways to watch it. So, same station can be found on more than 1 channel. That's kind of a key right here. More than 1 way to do it. No, not a function. And we'll talk about those later. I don't want to get into that. I just want to get into the rest of those because this is actually what we're going to be doing in this chapter is graphing these functions at some point. So some more examples here. Again, a little hard to read, so we focus on the x's. -2, -1, 0, 1, 2. Notice I didn't look at the y's. I don't care if the y's repeat. Is there any repetition in the x's? No repetition. Yes, a function. B, 4, 8, 6, 4, 5. Oh, I've got repetition there. The 4s went twice. Not a function. Again, did the x's repeat? Yes, they do. Not a function. Now, if I look at this mapping here, -1, 3 to 15, 11 to 15. I don't care if 2 of them map to the same number. That's not a problem. That would be like y's repeating. Not a problem. As long as this doesn't have 2 different outputs for x, that's okay. All right? So let's continue. We just did that. Let's roll through this. So let's talk about looking at these graphically a little bit more in depth. Write this down. It's called the vertical line test. Graph represents a function when there are no vertical line passes through more than 1 point of the graph. So it could be a graph of a bunch of dots. All right, this is called a discrete graph, or it could be a curved graph, continuous. But can I draw lines through each without hitting anything else? If you can draw a vertical line, that's why it's called the vertical line test, through each point without hitting another point, then this passes. If I hit it twice, if I draw a vertical line and I hit 2 points, not a function. Okay? Don't worry about the continuous or discrete part. That's got nothing to do with it. Do I hit it twice? So here we go. Right here. Vertical line. Vertical line. Did I hit 2 points? I did. That failed. Not a function. B. If I draw vertical lines, will I hit this in more than one spot? Nope. So I pass the test. That is a function. Again, write this in your notes, pause if you need to. So here we go. Number 5. Take a look. Can I pass the vertical line test? I don't hit that at all. So this right here passes the vertical line test. Number 6. Run vertical lines through here. I don't hit it twice anywhere. Passes the vertical line test. Number 7. Take a look. Failed the vertical line test. Number 8. Do I hit it anywhere going vertically? Do I hit 2 spots? Nope. So it passes the vertical line test. So, next concept, domain and range. Domain is your inputs. That's what you plug in to the function. Your range is your outputs. That's what you get out of a function. So, domain, find the domain and range of the function. Okay? So, what are the x's here? Well, first let's just look at these as coordinates. So this right here would be -3, -2. That's this point right here. You should be writing this down. This point right here, left 1, up 0. That's -1, 0. This point right here is right 1, up 2. This is right 3, up 4. So there's my coordinate points that I'm looking for. So the domain messed that up. Nice little fancy bracket there. Your domain is your inputs. Well, remember we talked about the graph. The inputs are the x values. So my domain, I just write down the x's. That's my domain. Take the x coordinates from each point and list them. My range is my y coordinates. Again, I just look at the coordinates and list them. That's why it's really helpful to write the coordinates down. So here I have generally speaking, you want to write these in order smallest to least, right? So there's my domain and range. I mentioned a couple of words earlier, and I just kind of mentioned them quickly. Discrete and continuous. I'm going to talk about that real quick. It's going to be a big part of tomorrow's lesson. I think it's tomorrow's lesson. Might be today. Discrete just means it's a bunch of dots. It's nothing of the stuff in between. There's no lines. Okay, that's a discrete graph. A continuous graph has lines. That's the difference. Okay? On a discrete graph, your domain and range is a list of numbers because it's only those numbers. A continuous graph is a little bit different. We can't just list numbers because this is all the points in between there. So I can't list all the points because it's all of them. Everything here. So everything where? So if I look at the domain of this problem, if I look at the inputs, if I look at the x's, remember domain means all those things. Input, the x values, okay? Range, your y values. So if I look here, and I know it's continuous, from where to where did I draw the line? What is the smallest x value? Well, I look right here. It kind of starts right there at -2. Where does it go? Well, it goes, how far right does it go? Well, it goes right here to +3. Do we have some way to indicate, some way to say or some way to write all the stuff between, hint, hint, -2 and 3? Do we have some way to do that? If only we had some way to indicate, some way that we have recently talked about to indicate that we have everything between two values. If only. Hopefully you've picked up on the hint. If I'm between, I use my notation from the last chapter. Remember, that's how we did betweens. So I'm everything between -2 and 3. The left value, the smallest value of the x's. Remember, I'm only looking at the x's here. I'm not looking at how far up and down the graph goes. I'm only looking at the x's. How far left, how far right. Well, my leftmost value is here at -2. My rightmost value is here at +3. So I go from -2 to +3. Now, the range, the y's. The range is up and down. What is the lowest value? Now you really got to switch your thinking here. This is a little confusing when we first talk about it. How low does it go? All right, it's like a limbo. Well, if I look up and down, I'm right here. Where is that? That's -1. How high does this graph go? Right and left. I'm not looking at these numbers here. I'm looking up and down. Well, the highest point is right there. That's the highest point, +2. So how do I write betweens? Well, just like that. That's my range. Why did I use y here and x here? Well, because your domain is the x's, your range is the y's. It's different variables, it's different information. We'll do it again. Can be a little confusing, you'll get the hang of it. So, domain. First off, when you have a discrete function, write down all the points before you do anything else. Quit being lazy and do it. So this is -2, 4. This is -1, 2. This one is 0, 0, 1, 2, 2, 4. Okay? Write down the points next to the dots. If you're on the computer, obviously, sketch it out on a piece of paper. Quit being lazy. Sketch it out and do it right. So my domain is a list of the x's. Range is a list of the y's. Again, we want to go smallest to least, so I should be scanning bottom to top here. Don't scan this way. Scan bottom to top. Smallest y is 0. Oh, it repeats. That's okay. Those repeat. That's okay. It's okay if my y's repeat. And right now, it's okay if my x's repeat. This didn't say anything. Oh, it does say function. So none of your x's are going to repeat anyway. It's okay if the y's repeat. That's it. I'm just writing a list of x's and a list of y's. Domain, range. Domain, x's. How far left does this go? Well, the leftmost point is right there at +1. The rightmost point is right there at +5. So I am between 1 and 5. range. When you look at range, scan bottom to top. Don't scan left to right. Left to right is domain. Bottom to top is your range. What is the lowest point of this graph? Don't tell me it goes here to here. I don't want you looking at it like this. You are scanning bottom to top. What is the lowest point of this graph? Right here. The lowest point of this graph is 0. What is the highest point of this graph? Goes from 0 to 4. That's the range. Take some practice. You need to make sure you're adjusting your focus. Domain is left to right, range is bottom to top. All right, word problems. So it says the function, and I'll rewrite this, y equals negative 3x plus 12 represents the amount of fluid in ounces of juice remaining in a bottle if you take x gulps. So just to make a note, it's x is the number of gulps, y, that's an F, y is ounces, just so we know what we're talking about. So if I take, I don't know, identify the independent and dependent variables. So, new thought here. Independent and dependent. The independent variable is the one that's inside the problem. Inside. So if I look here, that is my independent variable, the one that's in there. The one I would plug in for. I would plug in for x to find y. The dependent variable is the one that it's solved for, y equals, the one it tells you to find. Like it says, the function represents the number of fluid ounces. That might be a bad hint right now. It'll make more sense later. But in fluid ounces of juice remaining in the bottle after you take x gulps. So I got a water, 1, 2, whatever, okay? How much is left in? That's what I want to find. Whatever it's solved for. This right here will always be your dependent variable because it depends on how many drinks you take. The answer depends on something else. How much water left in the bottle depends on how many drinks you take. So this depends on this. That makes this the dependent variable, and this is independent. I can take however many drinks I want until it's empty. So A, identify the independent and dependent variables. So the independent is x, dependent is y. The domain, 0, 1, 2, 3, and 4, what is the range? So it's giving you a domain. It's giving you the input. Remember what we said here. I think I erased it. Domain is input. It's telling you what to plug in. It's telling you to plug in these values. So you can do it however you want. I'm gonna make a chart. That's what I'm gonna do, okay? Domain is 0, so if I plug in 0, here's my equation. Plug it in, do the math. Negative 3 times 0 is 0. 0 plus 12 is 12. If I take 0 gulps, there are 12 ounces left. Do it again. Next number in the domain is 1. Negative 3 times 1 is negative 3. Negative 3 plus 12 is 9. If I take 1 gulp, there are 9 ounces left in the drink. Do it again. every one of those values, you need to find the range. For every one of those domains, you need to find the range. So, if I plug in 2, I get 6. Just to make this a little quicker, if I plug in 3, I get 3. If I plug in 4, I get 0. What is the range? This is the range. So again, usually we write that least to greatest. So the range, I don't know if this is shown on the video or not, 0, 3, 6, 9, 12. Just write them out. So lots of things going on here. Dependent is the one it's solved for. Independent is the one you plug in for. Write this in your notes so hopefully you remember it. When it gives you a domain, those are the numbers you plug in. The range is the answers you get out. So, the function A equals, I'll make this bigger, represents the number of avocados you have left after making B batches of guacamole. Identify the independent and dependent. So if I look here, which one is independent? Which one would I plug in for? Which one is in the problem? Like inside the problem? B. Which one is dependent? A. Domain is 0, 1, 2, and 3. Find the range. I can let you work on that. I just want to talk about the independent, dependent. Plug those numbers in. So, function. (19m plus 65). Identify the independent and dependent variables. The independent, M. Dependent, T. All right, recipe calls for an oven temperature of 350 degrees to describe the domain and range. So this one's actually asking you to work backwards. It's giving you a final temperature. It's giving you a range, and you need to work backwards to find the, so this one you would work backwards. You would put 350 equals 19m plus 65. It's giving you the final temperature. Subtract, I don't know, I don't have my calculator up here. It's like 285 divide 19, 5, 15? I think it's 15. Double check my math there. I think it's 15. So it's asking you to describe the domain and range of the function. Is the domain just going to be 15? Is that it? 15 minutes is the answer? Is that how ovens work? They just automatically are 350 degrees? No, that's not how an oven works. It slowly heats up. So the domain, my inputs, is going to be between 0 and 15. Because it's going to take 15 minutes for it to happen, but it's going to slowly warm up. My range is going to be 0 and 350. Because it's going to start at 0 degrees and slowly heat up to 350. All right, so this is an example of something that would be a continuous problem. Because it's not going, okay? It's continuously warming up your oven. All right? We'll talk more about it as we get rolling here. I think that's all I got. Yep, that's all I got. That's just another one of the same ones. So, lots of stuff here in our notes. We talked about independent, dependent. We talked about domain and range. Domain is the input or the x's, range is the output or the y's. We talked about all the different ways that we can tell if something is a function. Looking at a graph, does it pass the vertical line test? We talked about, do x's repeat? If x's repeat, it fails. If x's do not repeat, it passes. It's okay to have the same y. It is not okay to have the same x. All right, boys and girls, get to work. Enjoy. Kind of a long one today, but we had to get a lot of stuff laid out there.